All right, so I'm redoing this video so it's a little bit easier to see how I'm using written arithmetic with a concrete manipulative, but this is how you can use a visual model, an area model, to showcase or to show why division algorithms work. So I'm doing a fairly simple problem right now, 132 divided by 6 going into 132. And the premise of this is that we know that there is a rectangle that has the area of 132 square units, square centimeters in this case it will be. And we know that one side of that rectangle is 6 centimeters. And I'm going to use array rods to show this. So array rods are color-coded links that on one side you see the number, so this is 6 and this is 7, so it's 7 centimeters. But on the other side you can see that there are the individual counts. So this is one row of 7. Now when we're doing multiplication, if I have, flip that over. So if I have 3 7s right here in a row, now as adults we know that 3 times 7 is 21. We have that memorized at this point. But for children that's harder to memorize, and so they can actually see conceptually that this is 3 rows of 7, so they actually understand what the multiplication means. And then there are some nice tricks that we can show them with this, which I'm not going to go into here, but this is just kind of showing what the material is. We don't need 7s right now because we're doing 132 divided by 6. So we know that we have a rectangle, and one side of that rectangle is 6 centimeters. So we know that one side is 6. We don't know what the other side is. So we have to be able to fit 132 square units in this area. And we're going to do it using long division. So I can put a load of 6s down here and just repeatedly subtract 6s. That seems like it would take a long time, and I really don't want to do that. But maybe there's a chunk of 6s, like an easy chunk of 6s that I can put here. Maybe I can put 10 6s. So 10 6s. Well, 10 6s is 10 times 6, right? So 10 times 6 is 60. So I'm going to put a 60 here. So what I just did is this is a 60 flat. So you can see on one side it says 60, and on the other side it's 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, 7, 8, 9, 10. 6 times 10, there's 60 square units here. So, but I can put 60 here, right? Which we know, here's a 60, and that's the same as saying 6 times 10. So for some of you savvy teachers that may have seen this already, you kind of know how this is going to go already, but I'm going to continue on. So I think that I can probably fit more 60s in here, right? Because if I subtract that, I get 72. So I think I can fit another 60 in here, right? That's another 6 times 10. Important to write these out here. And then now I have 12 left. Okay, well, I can't put another 60 there, but I can put another 6, and actually 2 6s here, right? So now I have 2 6s, 6 times 2, and that's 12. And now I've filled out this entire rectangle, and this entire rectangle should have 132. So 60 plus 60 is 120, plus 6 is 126, plus 6 is 132. So on this side is 6 long. On the other side, how long is this other side? Okay, so here's a 10, here's another 10, and here's a 2. So I'm going to zoom in a little bit so you can see this. Okay. I'm just kidding, this thing doesn't want to move. So you can see it a little bit better that way. So there's the 2, the 10 and 10, so that's 22. And if you look right here, 10 plus 10 plus 2, that's 22. So this is a nice way of beginning that transition so students will eventually learn long division, But this right here is not technically long division. It's the partial quotients algorithm, because you're showing each of the pieces that you're taking out at a time, and you're doing it by place value. So this is a lot more meaningful than saying, okay, how many times does 6 go into 13? Because this is not 13. This is 130. And you're not figuring out how many times 6 goes into 13. You're figuring out how many 6s go into 130. And there's 20 of them. So this is getting students to start recognizing this. So after a while, kids won't need to do 10 and 10. They'll be able to start lumping these together. So eventually this will be 6 times 20 and 6 times 2. And then it'll be a much easier transition to a more standard algorithm or standard approach. But beyond that, because let's face it, we have calculators on our cell phones now. Adults generally don't do long division. So that's not really a great end goal, but they will actually understand what the heck it means, and that's a great end goal. So, nice, straightforward example of how this actually works. My one recommendation is, by all means do this, but practice this first. Don't try to do very complicated problems, because that becomes messy with this. So you don't want to do 27 into 4,382. You don't do that with manipulatives, because, well, it's borderline child abuse. You just don't do that. So practice the problems yourself. If it's kind of a pain for you to do it as an adult, it will definitely be a pain for the kids to do it. But otherwise, nice, straightforward. Make sure you always have the written version paired directly with the concrete version.